Good afternoon, everyone. Can you all see and hear me? Hello again to most of you, I think. Tell you what, I'm exhausted. It's more tiring doing these than it is classroom training. Anybody's first time in here? I recognise so many names. Anybody in for the first time? You all done some sessions with it? Just as usual, guys, if you've been here before, you know, we'll just hang on a minute or so, just to let everyone get in the room. There's quite a few registered for this, guys. I don't know if everyone's going to turn up, but there's quite a few that have registered for it anyway. So. Can't get this thing to work. Here we go. That's better. Okay, just a few first timers then. Well, welcome. I think we've got most of those that are coming. We've got quite a big group, guys. We've got about 39, 40 in it. So, yeah, quite a big group. Hi, Gareth. Gareth Phillips. He works with us here at Sygma. He's one of our trainers and assessors. He's obviously just jumped on to make sure I'm doing a good enough job for you. Been watching over me. My dad was on one this morning. I'd put a link on social media and my dad decided to join in and have a look. Okay, guys, my name's Pete Ashcroft, for those that haven't met me before. For those that have been here a few times, you'll have to listen to the intros again, I guess, but for the new people here, I'll make it very brief. I work for, wrong hand, it's all reversed on here, Sygma Solutions. We're a specialist training company in utility, location and avoidance. We do 1 day Genny and CAT courses, 2 day courses. We do 5 day utility surveyor training. We do higher level utility mapping qualifications. But everything that we do in terms of training is all geared around utility location. We kind of specialise in one subject. I may have trained some of you in the past. I don't know. My background personally, I started my locating life off working for Radiodetection. I think I just turned 20. I think I was 19, just turning 20. So long time ago now. I started with them, did a few years there, working with some utility mapping companies, got more and more involved with training as I went on. So it's all I've ever done, and I hope I can share some of my real life experiences with you today. There's a lot of myths out there about cable location and stuff. Maybe try and cover some of them as we go through the session today. So that's a bit about Sygma and a little bit about me. A little bit about the software. We're still getting to grips with it. It seems to be working quite well. The only downside is, and apparently it's the same on many platforms, is that there's a delay. So when I talk, you tend to hear me about 7 or 8 seconds later. I want to keep these interactive. I encourage you to question me and ask questions and get involved, and I'll be throwing some questions out to you guys. But it takes, as I said, about 7 seconds for you to hear the question, which therefore means there's a bit of a delay with me seeing the answer. So just bear with me, guys. It's the best that we can do, and it just means there's a few pauses in between as we go. These webinars that we're running are extracts from our training courses. If anybody was on the previous one with me this morning, it was on about how to get the best out of the Genny. And let me just explain where this one fits in that you're going to watch now, because the title sounds quite negative. It's called The Problem with Power and Radio. And I guess this section is a little bit negative, but you need to see where it fits into the program. And what we're always trying to do as a training provider is get people to use the transmitter and change the behavior of how they actually scan a site. And I know we've got some utility surveyors in here, and this might seem odd to you guys, but a lot of the guys that are using cats and jennies on site, the guys doing excavations, they rely too much on passive scanning. And one of the big challenges that we have is to get them using the transmitter. And I know that if you're a utility surveyor, you'll kind of do the bulk of the work with the transmitter. So we use this section to show people the problems with power and radio, and encourage them to use the Genny. So just so you understand where it fits in, I don't want you to think I'm being critical of equipment or anything. It's just to show the differences between passive and active locating. The chat's gone quiet, guys. Can you all still there? You'll still hear me? Still getting used to this. It's really strange not having faces looking at me, being able to see if you're asleep or if you're listening or whatever. Yeah, cool. The other thing to remember as well, guys, Ben's just reminded me actually, because I know Ben is from Australia. I'm not sure what time it's over there, Ben. But this is aimed at the UK market. There'll be similarities, but when we talk about a few things, bear in mind it's aimed at UK. So, without further ado, we will crack on. The first thing that I want to touch on with you guys is just, come on, next slide, please. There we go. You just have a quick look at some cable locators. Don't know if you guys can relate to any of them up there. One of the thing that I find amusing with the cat is it's a bit like the word Hoover. You know, everyone calls a vacuum cleaner a Hoover. It's the same with a cable locator. Everyone calls every cable locator a cat scanner, which isn't strictly true. The original name cat was a brand name of Radiodetection, and the top picture here is to show you how the cat itself has developed over the years. So we had the Mark 1 up to here, and Mark 2, Mark 3, and the Mark 4. They've not got bigger over the years. They're not like smartphones. They're all the same size, but it's just, I think it's supposed to like the evolution of man picture as it goes through. But that's the range of the original radio detection cat, if you like. The bottom picture along here, guys, just shows a wide range of cable locators. There's various cats on there. There's ID400s, 4000s. There's the Leica locator, the new V-scan on there by Vivax, C-Scope. There's a wide range of locators on there. I'm guessing you guys in here will be using different ones. Some will be using cats, 8000s. And the point of showing you this is the theory that I'm going to go through, this basic theory of passive scanning, is applicable to all of them. Okay. Yes, these locators are different. They do different things. Some are better than others. Some give you more information. But in terms of the fundamental way they work, they're the same. And what I always find interesting is when people ask which is the best one. Because a lot of that depends on what you're doing with it. Okay, I've had it where people have said to me before, I've just bought an RD8000, and I say, why have you bought that? And they say, it's better. And I'll say, well, why is it better? And they usually can't answer. So it's about having the right locator for the job that you do. So there's a range of locators, and they all work on the same principles. So this one here, guys, is one of the earliest records captured of people using the same technology to detect an underground cable. Because what a cat is, it's not like a metal detector, it's a magnetic field detector. The nearest comparison you can make to a cable locator is actually a radio. Inside our locator, we've got aerials, we've got a tuning system and a speaker and an output. For those using 8000s, you've got the F key, frequency key, just cycles through the different frequencies. It's a bit like having a car stereo where you've got 5 buttons all memorized to a different frequency, and you're skipping through them. So they're electromagnetic field detectors, really. And what you can see on this picture, guys, you're probably looking at that and thinking that's a roof truss, not a cat, and you'd be spot on. But if you look at the bottom right-hand corner down here, you'll see this little white line here, and that's actually a cable. And what they've done here is they've used the roof truss to create a frame and then wrap the wire around it to create a coil. So you'll hear me talking about aerials today, or antennas, and an aerial in the sense we use it is a coil of wire. And what's happened since then is what they've realized now is that rather than using a big frame and wrapping a wire around it once, you can actually use a small frame and wrap the wire around it many, many times. Okay, and that's where our antenna is in the cable locator. That makes sense, guys? You okay so far? So that's a magnetic field detector, just like a cat, guys. Yeah, and this is the same for your 8000s and your other locators out there. Same kind of thing. We're picking up that magnetic field coming off a cable. I don't know if anybody in here remembers being at school, whether you did. There's an experiment we used to do with a bit of paper and a magnet and some iron filings, and you sprinkled it over the top of the paper, and you got a nice, pretty wave pattern. I don't know if anybody did that or not, but it's a similar kind of thing. If you could see the magnetic field coming off the cable, it would look like that. It's a cylindrical field coming off that utility, and that's what the cat's detecting. The way I try and simplify this, guys, is think about throwing a pebble in a pond. If you drop a pebble in a pond, you get a ripple coming off it, don't you? The cat's detecting the ripple, not the pebble. And this also answers the problem. I speak to so many guys out there doing this, and the question I often ask, which I'll chuck out to you, is: have you ever been using a passive mode, power or radio, and you've detected one signal when you know for a fact there's more than one cable there? You could have 2 or 3 or 4 or 5. I think the worst I had it once was in a street in Dundee city centre, I think it was. And we were lucky that the footpath was opened up so you could see everything. There's about 14 utilities in there, and we got one power signal off the lot. And that's what often happens. So I don't know if you've experienced that, guys, where multiple signals appear as one effectively. And to describe what's happening, imagine getting 4 or 5 pebbles and dropping them in a pond at the same time. Can you see what would happen? Can you see how hard it would be then to differentiate between them all? And for those that were on the Genny session earlier, that's what we're trying to do with the Genny. You see, we're trying to find one pebble at once. We're trying to put a signal onto one utility and locate it. Okay, so that's what quite often happens with passive modes. They blend into one. So that's what the cat's detecting is that magnetic field coming off it. Okay. So we'll look at power and radio in a little bit more detail now of what they're actually doing. So remember, I talked about it being a frequency, a radio station in a sense. Power's picking up 50 hertz, electrical power energy, and radio is about 21 kilohertz. The only benefit of passive scanning, to me, is speed. It's quick. It's often unreliable. It's often inaccurate, and it often misses things. Again, going back to share some of my experiences with you guys, and again, you might be able to relate to this if any of you guys are involved with safety or you're in charge of a group of lads. You often ask some of the older guys out there using cats and Gennys, and they'll often tell you that the older kit was better, the old Mark 1 or the old Mark 2, that they were better. And I'm not going to get into that debate. There is a difference between old analog and digital locators, which we'll not get into. But the other thing that people aren't realizing is that in the UK, the networks have been changing over the years. And modern power cables do not give off that same signal that the old ones do. Okay, they just don't give it off. And again, on a normal, long course, we go into this in detail, but we get different signals off modern cables. So can you see the more and more modern power cable that we put in the ground, the less effective a cat seems to be on power because they just don't work as well. Okay, make sense, guys? Hope so. So when we put the cat on power mode, we'll deal with power to start with. Yeah, when we put the cat on power mode, we're picking up a 50 hertz magnetic field. Again, that's in the UK, guys. So for example, in America, it's 60 hertz. So cats are different specification for the States than they are for the UK market. For those using an RD8000, go into your menu, go to the power setting, and you'll see there's a choice between 50 and 60 hertz. Yeah, make sure it's on 50 if you're using it in the UK. I've seen quite a few people out there in the UK with it on 60. So that's why you have that setting, guys, for different markets. So it's picking up 50 hertz. And the reason for that is that we use alternating current. Alternating current is current that goes backwards and forwards like this. And when we get that alternating current, I'm just going to make me a bit bigger because I'm going to do a few bits of stuff with my hands. There we go. So we get this alternating current going side to side. And that generates a magnetic field. All that hertz means, guys, is cycles per second, basically. So it's doing this 50 times every second. The thing that's important to understand from our point of view, guys, is that we only get a detectable 50 hertz magnetic field off a utility when there is a current being drawn down it, not a voltage. Okay, difference between current and voltage. So we have to have current flowing down it, and we only have current flowing down it when there's something actually in use, turned on and in use. Okay. That's what we have to have. So let me give you an example. Think about the power cable that goes to your house where you live. Go inside your house and turn everything off. Turn absolutely everything off. Even go to your meter and turn the main switch off for your electric meter. Does everyone understand that your power cable that feeds your house is still live and dangerous? If you dig through it and hit it, it's still going to go bang. It's still live. It's still dangerous. However, because we're now not pulling a current, the cat will not detect it on power. Even though it's live and dangerous, guys, yeah? We've got to have current. And the other thing we need to consider as well is how much current do we need? If I've got a cable to a house that's buried 1/2 meter deep, and inside the house, let's say there's a fridge freezer on and a TV on and a light on, etc., that still might not be enough. Okay, but if I go in the house and put a kettle and a microwave on, then I might find it. But if that cable's buried more than 1/2 meter deep, if it's 1 meter deep, I might need more than a kettle and a microwave on there. Get the idea, guys? And people ask, how deep will a cat work to on power? How long's a piece of string? Some cables you won't get till you touching them. Some you might get into a meter. It all depends on how much current's flowing. But the point where I'm going with this, guys, is we can't control it. It's out of our control. We can control the transmitter signal. We can apply that where we like. We can't control. Well, I suppose you could go knocking on people's doors and asking them to turn a kettle on. Yeah, you might get a brew as well at the same time if you're doing that. Okay, but practically, really, that's where the transmitter comes in. So just let me give you a little example, guys. Again, it's hard on video. I'm just gonna. This is the first time I've tried this. I'm going to give this a go and just see if this works. Okay, so you should see a full screen version of me. You'll notice I have a heater set up here. Let's see if this works. So I'm going to put that on that cable. That can you see the cable here, guys? It's just out of shot, but I'm just on this cable here touching it. This cat's on power and it's switched on. Yeah, that cable is live, but I'm not detecting it. But if I turn the heater on, I don't know if you can see my hand here. A little switch on the heater here. You see that? Off. So the heater's off. Cat's not detecting it, but that cable's still live and dangerous. If you've got good hearing, you might actually also be able to hear the subtle change in strength. The heater's got 2 settings on it. So that's both on. That's 2,000 watts. Did you hear that subtle change then, guys? Listen again. 2,000 watts, 750, yeah? Both off. Gone. Did you all see that okay, guys? That's the first time I've tried doing that on here. Did that make sense, guys? All right with that? Great. Okay, let's carry on. So now you understand power. Let's look at some of the examples, guys, now then. I'm going to give you a few silly examples. But they're also true examples. Imagine you're out in a footpath and it's 8 o'clock in the morning and everyone's getting the kids ready for school. Well, not at the moment in lockdown, but in normal times when everyone's going about their business and going to work in school, you can see that 8 o'clock in the morning, getting the kids ready for school, kettles on, you can see there's quite a bit of current being used. So you might detect that cable in that street. Go back to the same spot at 11 o'clock in the morning. What's going to happen now? That people have gone out for the day, dropped the kids off. Can you see the current level? It's going to drop. So you might not detect it. So this is where I'm going with the unreliability bit. Can you see we can't control it? It depends on what's being used at that particular time of day. Okay, so you can, on power, detect cables depending on the time of day. And one of the advantages of doing training courses so often is quite often we're in the same street over and over again, and you can genuinely see that on different days you get different results. The weather has an impact on it. Imagine a sunny day and then compare it to a day where it's gone colder and pouring down with rain. See what I mean? Can you imagine the consumption, how it changes and things? So it's a variable signal we can't control. I know I keep repeating that, guys, but it's just to emphasize that point that it's out of our control. I live in a place called Wigan, and in Wigan we have streets where people go to work and we have streets where people don't go to work. So can you see how you'd get different load in those two different streets as well? What about other examples, guys? So just to finish off on that, guys, let me just come back down here in a minute. Where's my cursor gone? This is just like an example of that, guys, just to see if this works. That's kind of showing you, like, you know, a big load on the cable, if you like, and less load on the cable. Yeah. So there's the limitations of power then. Think about other real things in the street in the UK. Street lighting cables during the day, not turned on, are they? The cables to them, though, are normally still live. They're not turned on. Services to houses, you know, buildings. And these are the kind of cables that get hit. If you look at strikes in the UK, it's generally street lights, services, all the stuff you can't find on power. What does that tell us? We're not using the Genny enough. Yeah. So there's lots of different examples here. Pot-ended cables as well, guys. Anyone that know what a pot-ended cable is? A cable that's been capped off. Okay. The other thing to look at with power is, and it's a bit technical, this, guys, but I think it's important. By the way, is this all making sense, guys? Again, just give me some feedback now and again, because it's really hard when I can't see you. I don't know whether you're looking at me with a confused look or a sleepy look or what. So hopefully it's making sense. The other thing we have with a locator is, I don't know if you know this, guys, but most modern locators are a twin aerial design, and there are a few reasons why we have that. But let me just go back to this one and show you what I mean by twin aerial design. If you look at this cat here, these are signifying the aerials. Can you see that? The top aerial and the bottom aerial. And one of the things that a locator does, think about this, guys. Magnetic fields don't just come off cables. They come off all kinds of things. They're around us all the time, especially on power, buildings, substations, you know, fencing, all kinds of stuff like that. It's giving off this magnetic field all the time. So a locator needs to be able to differentiate between, let's say, an airborne signal, a signal above ground, just background signal, and a signal below ground, yeah? And the way that it does that is quite clever. So if you look at the cat here, guys, let's say that I'm just outside on a regular footpath outside our office. Let's say the background signal level, just to give it a number, is 50 at the top. Yeah. The cat would need a below ground signal of 51 or more for it to respond, to get a noise from it, to get a buzz from it, whatever you want to call it. Okay, does that make sense, guys? I'm going to pause there because that's quite important for the rest of it to make sense. Do you understand that? So the signal at the bottom aerial needs to be greater than the signal at the top in order to get a response from a locator. Is everyone okay with that? Sip of water on it. Good stuff. I'll let your answers come in. So now imagine this. We now go to a different environment. Maybe we've got overhead power cables. Maybe we're near a substation. Maybe we're in a footpath and we've got kind of, you know, terraced houses at the side of us. You know, buildings giving off a magnetic field. What do you think is going to happen, guys? This 50 now has been increased to 100. Yeah. So what does the bottom aerial need to be? It needs to be 101 or more. And you see that, guys? So the more background signal we've got, the more underground we need. Again, we can't control this, can we? It works different in different scenarios. So many times I've had it where you've been near overheads and things, and the cat just doesn't work. Okay, so that's important to. And this is all locators as well, guys. You know, this is all locators. Let me show you an example, guys. Okay, I've got another example of this. Hopefully, this will make sense. All right, I'm going to try again. Another little example. Let's see if this works. Right, let me get my cat. Oh, hang on, guys. I'm going to go full screen again for this, just so you can see me. So if you can see me there, guys, I'm going to get my cat again. And once again, guys, I'm on this cable here. So just show you, can you see? I'm on this cable here. You should hear that noise coming through. I've got here a laptop charger, transformer laptop charger. Watch what happens when I take this near the top of the cat. Can you see that? Take it away. So now, that cat won't pick up the cable on power. Okay, did you all see that all right, guys? Does that make sense? Yeah? Now, again, this is not being critical of the cat. This is showing you why the Genny's important. What's the answer, guys? Bang a transmitter on it. Let's stop relying on power and radio. Let's get the transmitter out more and put a transmitter on it, because we don't have that problem, do we? Okay, get a transmitter signal on it, problem solved. That's what we're trying to go with this. Right. Now, where this is also a problem for the guys that are excavating. So for those that are involved in excavation stuff, this is one thing you really need to consider. For the utility surveyors in here, you might not know this, but under HSG 47, there's a requirement for us to repeatedly scan as we dig down. Yeah, Chris, you can, especially if it's ringing. Yeah, sometimes you can. So if you phone in your pocket, you know, near the cat, again, yeah, absolutely. It's a magnetic field coming off it. So sorry, I lost where I was in answering that question. Oh yeah, so we're told to keep scanning as we dig down. So the guys that are excavating, they're told to scan initially, then they take out a layer and scan again. You get that here? So they keep scanning as they dig down, which is great advice, and it's something that we encourage. But what we also need to make sure people understand is that there's a limit on that. Let me just show you what could potentially happen here. You might already see where I'm going with this. Yeah, interesting, Neil. HSG 47 doesn't actually, Neil's saying every 150 mil. HSG 47 doesn't actually specify a distance. It just says regular and repeated. But what you then find is companies and clients specify. So I think Scottish Water contractors specify 150. I think like Cadent is 300. So it's all different. If you're not sure of that, guys, and you are excavating, check with your company digging procedures what that distance is. But let's have this scenario here, guys. So we've got the ground here, we've got a cable here, we've got a cable down here, and we've got a cat. And we find that cable from the surface, no problem. Okay, we then start to excavate. Okay, and we dig down towards this cable, so we end up with that kind of scenario. You see it? And then we put the cat in the excavation. Bottom aerial. You get the idea, guys? I'm shit at drawing, but you get the idea. But basically what can happen is this cable here now does what I've just shown you. It can cause the cat to cut off. So I've had it before where guys have said they've picked something up from the surface, but then actually when they put it in, oh shit, sorry, I'm still full screen. I'm trying to draw this for you. Sorry, guys. Schoolboy error. Hopefully you got most of that, guys. So what I was... Idiot. I'm still getting used to software. I'm still a beginner, guys. All right. So bear with me. So we were saying that cable here from the surface, you find it with your cat. Then you start to dig out. So you then end up like that. This cable here, you put the cat in. That affects the top aerial. Make sense? Yeah. Everyone okay with that? Can you see it now? You still can't see it. Sorry about this, guys. I'm still getting used to it, so please bear with me. Don't get too frustrated with me. Yeah, got it now. Great stuff, guys. So the point here, guys, is yes, very important to keep scanning as we dig down, but we need to just make guys aware that, you know, if they do find something from the surface and it disappears when they go in, the cable's probably still there. It's just the way the cat works, okay? Or any locator, like I said, right? So that's on power, guys. That's the limits of power, okay? And what we have to watch for. So when you're on radio mode, guys, again, this is UK based, guys. It's going to be different in other countries. When we put the cat on radio, what it's actually doing is it's picking up military transmissions. It's signals that come from the MOD, and it's about 19 to 21 kilohertz that the cat's tuned into. And what the MOD do is they transmit VLF, very low frequency radio waves, to communicate with submarines underwater, basically. I know, sounds mad. It's true though. So And we spend a lot about this on frequencies on the high NDM stuff we do, guys. So I won't go into a lot of detail today. But basically, if they want to talk to a submarine on high frequency, they've got to put an aerial at the water. High frequency will not penetrate water. Which, if you think about it, it defeats the point of having a submarine, doesn't it? Because you can see it if it's got a thing sticking up. So they've developed a low frequency system that enables them to communicate while they're underwater. And the byproduct of that, if you like, is that this signal penetrates the ground and it's re-radiated off metal objects in the ground. Okay, and that's what you're picking up on radio, is this re-radiated signal. In the UK, it comes from Cumbria. There's two transmitter stations, guys. There's one called Anthorn and one called Skelton. You might see this if you ever drive to Scotland. It's a huge, it's actually interesting. It's the tallest structure in the UK. If you Google tallest structure in the UK, it's a Skelton transmitter. That's where it comes from. The reason I'm boring you with this is that I want you to understand, guys, that quite often your radio signal will depend on what's being transmitted. And it's inconsistent. Some days it's good, some days it's bad, some days it's off. And again, you know, I'm on streets over and over again. On one day, you can find something on radio, on the day after you can't, because it's up and down. There's a little website you can go to, like a monitoring station. It shows you when they're on or off. So this is just showing you a particular day, the signals that were on. And as you can see, the day after, one got turned off for a couple of hours. So it's just that point again, guys, like power. It's just that, you know, it's intermittent. We're not in control of it again. You see that? Again, Genny all the time. The transmitter is important. So these signals penetrate the ground and they're re-radiated off metal structures. What this slide's trying to show you guys is that what you'll tend to find here is this big metal pipe, big metal content, will generally give you a much better radio signal than a tiny comms cable. Think about how much metal's in that. You get very little signal off it. The other thing, and this is the one that a lot of people don't realize, and it's very, very important when it comes to cable location, is it must be earthed at both ends or continuously earthed. So the difference is that when you bury a metal pipe in the ground, it's metal in contact with ground, it's continuously earthed. Yep. When I bury a cable in the ground, it's insulated. Anybody on the Genny one with me before? Do you remember? Same kind of thing we're talking about, earthing. See how important it is and how relevant it is to cable location. Okay, it's got to be earthed at both ends. Not all cables are. So let me just give you a few examples. That BT going in the property, not earthed. Not going to find it on radio. Pot-ended cable, not earthed. Not going to find it. Modern house, PME, not earthed. Not going to find it. Yeah. So limits again, limitations again that we've got with these passive modes. Passive modes find signals but don't identify, guys. Pretty obvious stuff, this. And the point here is, you tend to get this from people that are quite new to it. They automatically think that because they found something on power, it's a power cable. I've had water pipes, metal ones, giving off power signals, gas, you know, all kinds of stuff giving off power signals. So I've had BT cables giving off power signals. So the point is, we can't identify. If you find something on power and radio, it is a service. That is all we can say. We can't determine what it is by what mode we find it on. We get induced signals jumping onto things from power lines, onto pipes, that kind of stuff. Okay. Why is it becoming harder to find cables? But this means with the cat on its own, basically. Do you remember at the beginning I talked about how the networks are changing and stuff? And before I expand on that, guys, one of the things that I want to do with you is actually show you, first of all, how a cat determines position. So if you, this is the same on every locator, guys. Again, we touch on this on the high NDM stuff. When you're using a locator, no matter what it is, you generally get one kind of response. You walk across that signal. I'm used to the old-fashioned stuff, so I still call it a needle, but it should be called a signal strength meter, I guess. But you have this needle that kind of goes up and then down, and you look for the highest point. I'm pretty sure that most people in here are aware of that. But what does that highest point relate to? So one thing I want to ask you guys, have you ever located a service and it's been in the wrong place? So you found something, spread it up, you dig down, it's a little bit out, or it's a mile out sometimes. Anybody ever had that before? I'm just going to get rid of me for a minute so I can draw on this screen properly, because I'm going to show you a few things on here. So hopefully you can still hear me. Let's make it easy to see that. So what a cat's actually, in fact, I need that video back on for a second. Do you know we talked about the aerial in the cat? What have I done with that cat? Oh. Here it is. So here, that's where the bottom antenna sits. Can you see it? Just over here. I've actually got an old RD600 here, and you can actually see it a little bit better with this. This is this 600. See that? It's an old RD600 antenna on the bottom. So what this antenna is, guys, is imagine a coil like this. Coil of wires, remember? Like that in the bottom. And the idea is that we sit that coil in the magnetic field and it passes through it like this. To give the rude gesture, okay? And that's why I'm sure everyone in here knows that your blade of your locator works at 90 degrees pretty much. Yeah, we're all aware of that, because imagine if I put the aerial in like that into the magnetic field, it wouldn't be able to pass through it. Okay, so it passes through. And what essentially happens is the highest reading you get from the cat, the strongest signal, is related to the angle of that magnetic field passing through that antenna. So when the magnetic field is horizontal like this, 100% of that signal will pass through. That's where you'll get the highest reading. We'll call it 100%. If the angle of the magnetic field passing through the antenna is, say, 45 degrees, we'd get maybe 50% passing through. And if the angle is vertical, we won't get any. Is everyone clear on this so far, guys, before I move on again? I know this causes a delay, but it is important that you understand this as I move on. While you're answering that, I'm going to turn my screen share back on again. I'm not going to forget this time. So if you look at the diagram on the left, this is what we call an undistorted magnetic field, guys. And I know you can't quite see it because of the dark line, but if I put the aerial here, can you see that the angle passing through is kind of horizontal, pretty much? So in other words, that'd be 100%. If I put the antenna here, it's 45 degrees, 50. If I put it here, 45 degrees, 50. So what that gives us is that shape that we're all used to, that peak. Okay with that, guys, yeah? That's why we get that up and down as you go. It's all about that angle passing through the antenna. What I want you to see on this one on the left is that, can you see the most horizontal band, and therefore the highest reading is always going to be directly above the cable. The problem we have, though, guys, is that we don't always get completely cylindrical fields. We often get what we call a distorted field, like the picture on the right. It kind of flops over to one side. Distortion is caused by many things, guys. T's, junctions, multiple cables, something nearby. There's a whole host of things that cause a distorted signal. And you can probably see the problem already. If I put the most horizontal part of that signal now is over here. So that's where I'm going to get my 100%. If I put the aerial above the actual cable, it's a 45-degree angle, isn't it? So I'm only going to get 50 there. And then here, again, I'm kind of going to get 50. And for those utility surveyors here, you guys will know this is where your peak and null comes in, guys. Yeah, so your peak and null settings are going to determine this. Okay, we're not going to talk about that today, but that's just where that links in with that about distorted fields. So you're going to mark the cable here rather than above it. Does that make sense now, guys, why sometimes your marks are out? It's nothing you've done wrong, really. It's just the way technology is, and you're locating a distorted field. It's that the higher end kit, the 8000s and things, using a system called peak and null can tell you this is happening. Okay. Again, guys, I've not got time today to go into massive amounts of detail. You can tell with a cat sometimes. Have a look at those two drawings. Have you noticed anything? Okay. The gap here and here is equal. Can you see that? But look at the gap here and here. Can you see the difference? So here we get like an equilateral triangle, and here it will be more like that. If that makes sense. And sometimes you can see that. And again, I've not got time on here, guys, but there's also a direct relation between these distances, so this and this, to how deep it is. And it's all to do with how these rings come out like this. All right. What I also want you to see here, guys, is if I just get rid of this for a minute, and you see how far out you are. That's how far out you're going to be. At that depth, black line surface. If we make it shallower, where's the horizontal point now? It's here, isn't it? Can you see that? So can you see that the deeper you go, the more out you are? Make sense? There's another reason why we should keep scanning as we dig down. It is true to say that the closer you get to a utility, the more accurate you tend to be, guys. Hope you understood that, guys. So now we know how a locator detects, how it pinpoints. We can now look at some of the issues we've got with modern cables. Just quickly show you this as well, guys. So this here, this was an 11 kV cable on power. The true position is here. The cap from the surface thinks it's here, but when we put it in the hole, it thinks it's here. So I don't know if this will make any sense to you guys. Come on. So just watch how the peak changes as we get closer to the utility. So we're talking before about old cables and new cables. So just a very quick example here, guys. On an old cable, the 50 hertz is generated by the phases inside it, like these things here. But what you got on these old cables is with this lead shielding around it. And what that did is it kind of shielded it and re-radiated at the same time. So what you get off these old cables is a nice round signal like this. I'm shit at drawing circles, but you get the idea. That's supposed to be a perfectly round signal coming off there. This is the new stuff, guys, going in. It's all over the place. Wavecom. It's a nightmare. The problem with Wavecom is there's no shielding in it. So basically what happens is the magnetic field on power that you detect off this cable is coming directly off the phases. And we call it Mickey Mouse ears. What you tend to get is, because of the shape of the phase, you get a magnetic field like that, and you get one like that, and you get one like that. Now remember what the cat's detecting. The cat's detecting the horizontal band, which is here and here. So in effect, in the real world, what that gives you is two power signals when the cable's actually between them. Well, that makes sense. Has anybody ever had that before? You might have experienced that. And also what happens is, if you look at my video screen and my fingers, the three phases are like this, and they twist like that, don't they? So we get a meter down the street, and it's all kind of gone to one side. Do you see what I mean? I've seen cables that looks like they zigzag down the street, and they don't. It's just where this magnetic field is. What is the solution? Using all the techniques that we did in my last presentation on the Genny. What do? We hook up to this cable, don't we? When we connect to this cable with a transmitter, or even if we induce onto it, which of those cores is that magnetic field going to come off? It's going to come from the Earth. And what shape is the Earth? It's nice and circular. Well, it would be if it wasn't for my drawing. You get the point. So the point I'm making here, sometimes guys say to me, Pete, why am I bothering putting a Genny on that? I can find it on power. Yeah, you might be able to, but it's nowhere near as accurate as banging a Genny signal on it. Make that effort to hook up, get a signal on it. There we go, guys. Short one there, guys. I hope that made sense. I hope you understood the context it was meant in. It's not being negative towards the kit. It's trying to encourage people to use a transmitter and explain the problems with passive modes. If you've got anything you want to ask, chuck it in the chat box. Again, give me some feedback, guys. You know, we've only recently been running these, so was it useful? Did you learn some stuff from that? Let me know what you thought. And you know, forgive the sales pitch, but when all this is over with, if you want to get us out on site doing some practical stuff with you, I'd love to show you all this in the real world. So yeah, I hope it was useful. I'll hang around for a bit. Just Ben, it's just an induced signal. It just induces onto stuff. We've got, I mean, in the UK especially, we've got power signals, but we use ground as a return path. Yeah, so we've got these stray currents in the ground all the time. So you know, going back to this example here, Ben, you know, we've got all these power signals, and it just induces onto other things basically, and that's why you can't tell what things are. You know, you get power signals off all sorts. I'm still here, guys, so good if you want to ask. I'm not sure what you mean by that. Is it virus? I'm not sure what you mean. You expand. Yeah, Neil, I'm still planning to do data download tomorrow. I haven't done one yet online. I'm just finalising the presentation. Supposed to do one, I think yesterday. We ended up cancelling because it clashed with the high NDM one. And obviously, we have one person presenting on this platform at once. So I'm hoping so. Good night, Ben. Thanks for tuning in, mate. Hope you found it useful.